Hello everybody, my name is Burak Kaan and this is dynamic project which is showing how to determine motor power for spider robot. Let's begin. First of all, I had to design the spider robot in 3D. I used SolidWorks for this job. I modeled two versions. Detailed var for rendering and measuring correct length of between joints, and simple version for analysis program. Before the calculation, I have to choose walking gait of robot, because it affects required motor power. I decide tripod gait. It's simple and reasonable. For this model, firstly L1, L3 and R2 rise up and moves forward. Then L2, R3 and R1. It can be easily understood from this model. I study and make calculation two different types, static and dynamics. Let's talk about static calculation. These are mathematical model for robot. As we mentioned, two legs up and two legs down. They are reaction forces. Angles are between leg. These purple notation torque values. W4 for body weight and other W's for motor weights. Leg weight is neglectable. I wrote moment equation for this, and this points. I wrote all these torque equation about 3 point which is I mentioned previous slide using mathematical modeling. I import the formulas to MATLAB for convenience. Flowchart explain how the code works. User input, collecting data from user, calculation are made by MATLAB, and in last part checking suitability AX12 motor for robot. AX12 servo motor generally using this type of project. It have 1.5 Nm torque. In MATLAB, this is code section, which is written totally by me. Input, data, equations. And in this part, required motor torque values are multiplied safety factor which is 1.25 because joint friction and motor friction and other things. Let's run the program. As we can see, leg actuator and hip actuator torque values and also checking suitability. For dynamic calculation, I used ANSYS for analysis and Excel exporting and saving data. In the ANSYS for transys part, I input earth gravity and rotation for each joints. Solution part, I input motor angular displacement, and when we solve it, the torque values per motor were calculated. I export the data in Excel. I exported the values to Excel to be more organized. I put the values in the table for easier understanding. Max torque values easily visible now. Although the dynamic calculation results are larger than static ones, AX12 will still be a reasonable choice for this robot because it has 1.5 Nm of torque.